Hello, and welcome to episode 7 of our series Back to Basics, Season 2. Today's topics are machine learning and deep learning, two very important topics in the machine-based decision support pillar that we explained earlier in this series. Let's jump onto the topics. From Wikipedia, machine learning, ML, is the study of computer algorithms that can improve automatically through experience and by the use of data. It is part of artificial intelligence. Machine learning algorithms build a model based on sample data known as training data in order to make predictions or decisions. Machine learning is the algorithmic foundation of both deep learning and predictive analytics. Deep learning, also known as deep structured learning, is part of machine learning methods usually based on artificial neural networks. By extension, it is all types of applications of these methods. The adjective deep in deep learning refers to the use of multiple layers in the neural network. This is different from the predictive analytics, which are based on statistical approaches such as trees, regression algorithms, etc. We saw those previously in episodes 1 and 5 of this Back to Basics video series. Neural networks are computing systems inspired by the biological neural networks that constitute animal brains, meaning our brains as well. A neural network is based on a collection of connected units or nodes called artificial neurons, which loosely model the neurons of a biological brain. Each connection, like the synapses of a biological brain, can transmit a signal to other neurons. An artificial neuron receives a signal, then processes it, and can signal neurons connected to it. The signal at a connection is a real number, and the output of each neuron is computed by some nonlinear function of the sum of its inputs. The connections are called edges. Neurons and edges typically have a weight that adjusts as learning proceeds. The weight increases or decreases the strength of the signal at a connection. Neurons might have a threshold such as a signal that is sent only if the aggregate signal crosses that threshold. Typically, neurons are aggregated into layers. Different layers may perform different transformations on their input. Signal travel from the first layer, the input layer, to the last layer, the output layer, possibly after traversing multiple layers multiple times. Neural networks learn or are trained by processing example, each of which contains a known input and result, forming probability-weighted associations between the two, which are stored within the data structure of the net itself. The training of a neural network from a given example is usually conducted to determining the difference between the processed output of the network, often a prediction, and a target output. The difference is the error. The network then adjusts its weighted associations according to a learning rule and using this error value. Successive adjustments will cause the neural network to produce output which is increasingly similar to the target output. After a sufficient number of these adjustments, the training can be terminated based upon certain criteria. Quickly, an example. When we look at a person, our brain uses a prototype of a face, the eyes, the nose, the mouth, etc., and processes the differences to the prototype in order to identify the person. An artificial neural network works exactly in the same way. The scalability of neural networks allows to address applications that require predictions of large number of things. Two main areas have been particularly using deep learning: natural language processing and image analysis. Other areas of applications have also used deep learning, such as bioinformatics. Let's dig quickly into these examples, knowing that each of them could be the subject of a Back to Basics video by itself. Speech recognition, often referred as speech to text, is the recognition and translation of spoken language into text. Without entering into too many details, speech recognition usually follows 3 steps. Acoustic treatment, that normalizes the sound input from the speaker, association to lexical elements, and decoding to provide the most probable text. If we consider all spoken languages and their accents, it's easy to understand the complexity of the task, meaning that huge training sets are required to perform speech recognition. With a few exceptions, only the GAFAM, Google, Amazon, Facebook, Apple, and Microsoft, can gather and process such datasets. As the training requires a real transcription of recorded voice to text, they are continuously using sample spoken text to improve their speech recognition capabilities. But this is only the first part. Now that we have a text transcript of the voice, what happens? We need to understand it. The term natural language understanding is an umbrella that can be applied to a diverse set of computer applications, ranging from small, relatively simple tasks such as short commands used to robots, to highly complex endeavors such as the full comprehension of newspaper articles or poetry passages. The applications of natural language processing are expanding rapidly. In our day-to-day life, chatbots are used for customer interactions in a variety of industries such as telecom, utilities, bank, and insurance, for instance. It applies in a wider context than text gathered with speech recognition. Here are some examples. Content indexing, for which specific information is searched to define indexes to find information quicker. Search engines use content indexes with other analytics. Entity recognition, which allows identifying specific information from texts, such as names, addresses, dates. Document classification, which automatically classifies the documents. Sentiment analysis, which extracts positive or negative feeling from a text. Speech and text are only a part of the usage of deep learning techniques. Image processing has a large number of applications. Image processing started in the 60s with application to satellite imagery, wire photo standards conversion, medical imaging, video phone, character recognition, and photograph enhancement. To simplify, image processing uses one or more of the 4 following components depending on the application. Classification. An example is medical imaging for skin cancer, where from the image of a benign and malign moles, deep learning is used to provide the probability of moles to be malign. Feature extraction is used widely in satellite imagery. It is widely used in agriculture to measure what area is planted with what plant. It also allows determining if diseases affect crops. These are used in precision agriculture, precision farming. Multiscale signal analysis is the basis of compression algorithms. From a set of pixels, an image can be compressed into an object containing most of its information with a much smaller size. JPEG format is an example for images, and MP4 is an example for movies. Pattern recognition is one of the most widely used image analysis methods. Its applications range from OCR, optical character recognition, to road sign detection, fatigue alert for drivers, or face recognition. OCR is used in invoice digitalization in SAP software, for instance. Apart from sounds and images, another type of data analyzed using deep learning is biological data. Bioinformatics combines biology, computer science, information engineering, mathematics, and statistics to analyze and interpret the biological data. Bioinformatics includes biological studies that use computer programming as part of their methodology, as well as a specific analysis pipelines that are repeatedly used, particularly in the field of genomics. The common use of bioinformatics includes the identification of candidates, the genes. Often such identification is made with the aim of better understanding the genetic basis of a disease, unique adaptation, desirable properties, especially in agricultural species, or differences between populations. The principle is to perform an observational study of a genome-wide set of genetic variants in different individuals to see if any variant is associated with a trait. Now that we know a little bit more about machine learning and deep learning, I will see you next time in the next episode, in which we are going to talk about data mining and data science.